A lonely spacecraft drifts past Saturn's golden rings, its hull catching the last rays of a distant sun. Beneath it, Titan's smoggy orange surface stretches wide, mysterious and untouched. Further out, Neptune looms in the dark deep blue, brooding and silent. These breathtaking worlds lie on the edge of our solar system, and for decades, they have been more fantasy than destination. We glimpsed them through flybies and distant telescopes, but truly reaching them, studying them up close, sending missions that could last, explore, even land has always felt just out of reach. Until now. Space exploration began with fire. The first rockets to escape Earth's pull did so with thunderous flames, launching astronauts into orbit and carrying robotic probes to the Moon and Mars. These missions were driven by chemical propulsion, fast, powerful, but short-lived. The engines ignited, burned fiercely, and then stopped. After the fire came silence. That silence has defined much of space travel. Once the rockets burn out, spacecraft coast through the void, conserving power, rationing energy, moving slowly toward their targets. Then came solar power. It brought elegance, simplicity, and longevity to missions in the inner solar system. Sunlight was free, renewable, and clean. Solar panels unfurled like wings, drinking in the light to keep instruments running for months, even years. But the sun's generosity has limits. With every million miles, its strength fades. By the time a spacecraft reaches Jupiter, sunlight is barely 4% as strong as it is on Earth. By the orbit of Neptune, it's practically gone. Past that, there is only darkness. The outer planets, those gas and ice giants teeming with mysteries, remained on the fringes. Missions took over a decade to reach them, often relying on gravity assists and tight power budgets. What we sent was limited. What we learned was incredible, but brief. These destinations were distant dreams, bound by the constraints of old technology. Then something changed. At a recent gathering of the world's top planetary scientists, a bold idea stepped into the spotlight, one that could rewrite the rules of space travel entirely. The concept wasn't entirely new, but its time had finally come. Nuclear fission, the same power that lights cities and drives submarines. But this time, shrunk down, refined, and prepared for space. Fission is the splitting of atomic nuclei, tiny pieces of matter torn apart to release vast amounts of energy. It's the fire of stars, harnessed in a reactor no larger than a small vehicle. In space, where sunlight fades and chemical fuel runs out too fast, this kind of power becomes a game changer. It doesn't flicker. It does not depend on proximity to a star. It just keeps going. For years. For decades. With this energy source, scientists are building engines unlike anything before. Some convert the reactor's heat into electricity, which then powers ion thrusters. These thrusters don't roar, they whisper. They emit a gentle, constant push that, over time, builds unstoppable speed. Others use the reactor to heat a propellant like hydrogen, which then blasts out in a high-velocity stream, generating thrust more powerful and efficient than any chemical rocket. Suddenly, everything changes. A mission to Neptune does not have to take 12 years. With nuclear propulsion, it could arrive in 5. A probe headed to Jupiter's icy moon Europa could carry more instruments, more power, and a longer lifespan. Instead of rushing through flybies, missions could orbit, dive, land, and stay. Scientists could study alien oceans beneath frozen crusts, watch methane rain fall on Titan, and search for signs of life with tools we previously could not afford to bring. Human missions benefit even more. With shorter travel times, astronauts are exposed to less cosmic radiation. They have more room for supplies, more robust systems, more power to sustain life in the vast cold of space. With a reliable nuclear source, they can travel farther, stay longer, and explore deeper. And still, that's only the beginning. Beyond the solar system, between the stars, lies the greatest mystery of all: other worlds orbiting other suns. Alpha Centauri, our closest stellar neighbor, is more than 4 light-years away. Using today's propulsion, it would take tens of thousands of years to get there. But with fission-powered propulsion, combined with advanced electric engines, that timeline could be cut dramatically. Not to a quick hop, but to something measurable in decades, not millennia. Imagine a spacecraft launching from Earth with a burst of nuclear thermal propulsion, gaining speed fast enough to escape the sun's pull. Then, as it leaves our solar system behind, it switches to long-duration electric propulsion, using its reactor to keep accelerating slowly but constantly across the vast emptiness. There would be no turning back, just motion, constant, relentless, determined. On board, the spacecraft carries more than fuel and metal. It carries questions. What is it like on Proxima B? Could it host life? Is there water there? Could we someday go ourselves? These aren't idle thoughts. They're mission objectives. Plans are forming. Designs are being drawn. We're getting closer. But it won't be easy. Fission propulsion is heavy. Reactors must be shielded, especially if humans are involved. The launch must be secure, no failures, no contamination. Public concern over the word nuclear still lingers, even in space, even where there's nothing to contaminate. The engineering is complex. The politics are sensitive. And yet, step by step, we are moving forward. NASA's Kilopower project is already building small nuclear reactors designed for use in space. They are compact, efficient, and built to run for years without maintenance. Meanwhile, agencies are testing nuclear thermal engines that could one day be demonstrated in orbit. The pieces are falling into place. What once seemed like science fiction is now a matter of development timelines. Soon, missions powered by fission will launch toward destinations we once only dreamed of. A probe might touch down on Europa, its systems warmed by a nuclear heart. Another might dive into Saturn's atmosphere, sampling gases that have swirled for billions of years. Others may head even farther, skimming the edge of the heliosphere, then bursting into interstellar space. Somewhere, perhaps a century from now, a distant spacecraft will send back an image of a new Earth-like planet orbiting another star. Not from a telescope, but from its own camera. Sent not from our solar system, but from another. A tiny vessel carrying our curiosity, powered by a core of fissioned atoms, driven by nothing but questions and hope. The story of space is changing. It began with flame and smoke. Now, it continues with silent, glowing engines humming in the dark. And this is not the end. The screen fades. The image of Earth, now a tiny blue spark, flickers in the background. The camera pulls back to reveal the spacecraft small, steady, unstoppable as it disappears into the stars. Strings rise in the background. A synth pulse follows, echoing like a heartbeat in the void. You've just seen the future one powered not by limitations, but by potential. And this journey is far from over. Next time, we'll go inside NASA's Kilopower program and look at how these reactors are built, tested, and prepared for launch. We'll explore the designs behind nuclear thermal engines and find out how they might one day send astronauts to Mars in half the time. We'll meet the scientists and engineers turning theory into action. If that fired up your curiosity, you are in the right place. Drop a like if you're ready to see humanity go farther than ever before. Got questions about nuclear engines or a dream destination in space? Comment below, we'd love to dive into it with you. And if you want to be here as this incredible journey unfolds, hit that subscribe button and turn on notifications, because we've got more deep dives, space tech breakdowns, and future mission reveals coming your way every week. Until next time, keep wondering, keep watching, and never stop reaching for the stars.